You are listening to the Effective Statistician podcast, the weekly podcast with Alexander Schacht and Benjamin Pieske, designed to help you reach your potential, lead great science, and serve patients while having a great work-life balance. So today I want to talk about the upcoming conference that happens in November 2024. So depending on when you are listening to this, it may be just a couple of weeks away. And we have a growing number of outstanding workshops. So for example, Evelyn and Andre will talk about elevating your LinkedIn profile to the next level to boost your career. I can highly recommend you attend this one because your LinkedIn profile is the number one resource that recruiters, hiring managers, lots of other people will check you out. And the better you are and the more keywords you have in there and these kind of things, the easier it will be for you to get new opportunities. In terms of opportunities, there's also lots of other kind of more technical things, like Daniel Sabanez will talk about Statistical Software Engineering, and he's an absolute expert in that. You can learn about machine learning from some colleagues from Bayer and Boehringer. We have a session about simulated and synthetic data generation with Darko. We have lots of things that will help you also personally, like personal productivity using Notion with Taina, or how you can use AI to effectively create content. So especially, for example, on LinkedIn, or also for all kind of other areas, how you can best do that. We also have Ulrike. She helps authors, especially also first-time authors, with their book. Maybe you actually want to write a book, and with Ulrike you can have a workshop to get into this book, especially also with AI support. So sign up for the Effective Statistician conference. Make sure you sign up for the premium version, not just the free version, so that you get access to all these wonderful interactive workshops. I'm producing this podcast in association with PSI, a community dedicated to leading and promoting the use of statistics within the healthcare industry for the benefit of patients. Join PSI today to further develop your statistical capabilities with access to the video-on-demand content library, free registration to all PSI webinars, and much, much more. Head over to the PSI website at psiweb.org to learn more about all the different PSI activities and become a PSI member today. Welcome to another episode of The Effective Statistician. Today I'm super excited to speak with Daniel. How are you doing?
I'm great. How are you?
Very good. So before we dive into the discussion, maybe you can introduce yourself.
Yeah. Hi, everyone. I'm Daniel Sabanez. I'm a statistician by training and kind of software engineer by experience. And I'm originally from the Munich area, then have been living in Switzerland for 15 years. And maybe by the time you hear this recording, maybe I'm already living in Taipei, Taiwan. And a little bit about my work. Worked a long time at Roche and in Basel, Switzerland as a biostatistician. Then spent 2 years as a data scientist in Google Zurich, and then came back to Roche for 4 years and now started our own kind of consulting company, Arconis.
Yeah. And we'll talk a little bit more about Arconis and that adventure at the end. So stay tuned. That's pretty exciting. So you mentioned you've been at Roche for a long time and then you went to Google. Why did you return from Google? Lots of people love to work at a company like Google.
Yeah, this is the kind of number one question that I answer when people hear about my CV. So it's not surprising to hear. Yes, and honestly, you know, if I was just thinking about financials, probably I would just have stayed at Google because the pay scale is just different than pharma, to be honest. But life is not just about money, right? Life is also about your interests and your passion and also the kind of work environment. And, it has been great at Google, nothing against Google. There were great people. They have a great team. They have a great technical infrastructure. We can probably chat more about that. But I was working in the advertisement business. And for me, while it was interesting because it was new and it was a completely different business than developing medicines or diagnostics, I did not see myself in this kind of advertisement space for a long time because I was just intrinsically more motivated to work in a kind of scientific kind of space where there's, there's some medicine involved at some point, there's some patients, maybe that we can help at some point. And it's not just about how many clicks we get here, how many conversions we get there, right? There was one reason to come back to healthcare. There was a small factor which was about commuting, because interestingly, Google kind of was very keen, but not very strict, but very keen on having, people in the office every day. So I basically was taking the train from Basel to Zurich every day, even though I took it late and I come back early. But, there was always this train factor involved as well. But that was another smaller factor. So it was mostly around being really interested in the kind of scientific work in healthcare to come back to Roche. Yeah.
Yeah, I love that. It's having a passion and following that is really, really important. And in the end, it's also motivating if there's just a bigger purpose for you that you're working on. And money is just not enough in that regard. Now let's speak a little bit about what we can learn as a pharma industry from Google. And given that you have worked on both sides, I think that is especially interesting. So from a technical point of view, what can we learn from Google?
Yeah. So of course, let's say there's always the caveat, right? That this is a completely different business, right? So, and that also is reflected in the kind of composition of the workforce, right? So when I was in Google, everybody was kind of mathematics, physics, statistics background, or some kind of nerdy field like that. Whereas work in Roche, obviously you have a much more diverse mix of backgrounds. And you have medical doctors, you have biologists, chemists. Of course, you also have statisticians and mathematicians and so on. But so I think that's one big difference that I noted also when I switched back and forth. Let's say the workforce is much more homogeneous in Google, where it's much more heterogeneous, and you have this multidisciplinary, let's say, challenges and opportunities in pharma, right? But let's say from a technical point of view, if we just talk about statistics and programming, of course, there's a lot that we can learn, and this is in particular around the way we approach, coding, right? Basically, everybody in Google more or less can code. And therefore, of course, you have very nice infrastructure internally available to help you that you have good quality of your code. And we have a lot of, you have a lot of rules in place. For example, you need to have code review for your code because before it can go into production, you need to have certain level of seniority before you can gain so-called readability for this certain language. And only then you can approve things for certain other areas and so on. So there's a lot of that, the kind of culture of quality around the code, right? Which is not that frequent, I think, at least in biostatistics in pharma, right? I think when you talk about statistical programming, there is a quality of code culture, I'm sure, in pharma, not just in Roche, but also in other pharma companies. You think about things like double programming, you think about things like validating things in code and so on. But I think in biostatistics, it's not that much yet. And I think that's definitely something we can learn. And that's also something that I try to instill and to infuse during the last few years in Roche, that we can improve a little bit this quality of software engineering, quality of coding within biostatistics. So that's definitely something we can learn.
So if you speak about this review, so you mentioned there's different levels of review. So do you have kind of qualifications for different areas? So that it's kind of, you need to be a master, a senior master, and super expert whatsoever to review certain things?
It was not that differentiated. So there were no different levels, but you needed enough experience and enough kind of accepted code changes before you gained so-called readability. So that was just one level, right? Either you have readability or you don't have readability. And I think by the time I left, they were just discussing whether they also introduced readability for R. Before, of course, they already had readability for C, C++, Python, Go, and whatever they use on the software engineering side. And they were just discussing they also needed for R. But that was kind of differentiating a little bit the more experienced and the less experienced people. Yeah.
So in terms of software engineering, where does just kind of coding stops and becomes more kind of a software engineering task?
Yeah, great question. I think it starts wherever you kind of use code twice. And that might start already when you write a little function to do things more efficiently, or you do things multiple times, right? Then it basically already starts. And then you already need to think about good practices, right? You need to think about, okay, do I document this function well? Do I make sure that, I can understand this function also in 2 years of time, or somebody else can understand it? Because I'll give reasonable names to things like variables and function names. I need to think about maybe writing some tests for these functions to make sure that they work also in the future on the different R versions, on the different package dependency versions, all of those things, right? So it starts already there. So not just when you write your own R package, or not just when you deploy bigger code bases or something.
Okay, so then that's pretty much for everybody that uses more than kind of proc-frac or something like let's have a little bit of a look into the data. So because I think you can't work effectively without kind of functions or macros or any kind of reusable code, so to say, even if it's used just within your environment for just the study at the start. So you mentioned the kind of the technical background or the technical environment at Google. And of course, there's the kind of the culture of quality, the culture of review. What kind of technical things do they use? Because I think they publish pretty much everything that they use as well, isn't it?
So some parts are kind of forked and open sourced, as far as I know, but many parts are also kind of strictly internal and they're not open sourced. So I don't have the latest, let's say, overview of all the, let's say, systems which are not open source and which are open source, of course. But I mean, that's also interesting, right? When you go into Google, you learn a lot of new systems that you have never seen before because they're just internally available. And you get out of Google, and for example, that was for me the case then. And then you start working more on kind of software engineering tasks. Then you find yourself also learning new things again, because you haven't been using things like GitHub.com, or you haven't been using things like even like Shiny, that was also really used in Google. You start thinking more around, how can I leverage the open source tools to things similar what I did before. So there's a little bit of difference. And I mean, many things I don't even probably understand really how they were built internally, but I just can tell you they were working very nicely and things were working very smoothly and so on. But I think I have to say now, I think what I see in the pharma space, with things like OpenStatsWare or Pharmaverse, also pushing more the software engineering topic, but also what I see in Roche in particular, the kind of status we have in terms of software engineering, it's getting much better, and it's not far away, I would say, even though we don't have all of these Google internal tools, but we use the open source tools, even though I think we're not far away from the way things are done. For example, when we talk about how our package is engineered or how our certain automation things implemented. I mean, it's already getting pretty close, which is great to see.
In terms of automation, that is maybe one of the things that's top of mind of people since I basically started the industry. Yeah, so people always want to automate, make some mundane things go away, and so that we can focus on the really value adding stuff. Yet my perception is that we have made a lot of progress in the last more than 20 years. Because my perception is overall, we more or less still do the same things. We have just added lots of additional documentation, lots of kind of standards, but these standards are so tedious that it's nearly impossible to kind of work with them. And I recently saw a post on LinkedIn that declared, well, this metadata-based automation is dead. It will not work. Yeah. What do you think about that? Is kind of better software engineering the answer to actually get these kind of things automated?
I think it's definitely part of it. And I also think it's definitely good to move away from written documentation, guidelines, or SOPs or something, move away from that, rather to encode written standard tools that are basically doing the job already. That, basically, so rather get into this mode of doing things rather than staying in the mode of just describing things, right? And I have seen in Roche, but also externally now, there's a lot of good stuff coming from these kind of automated workflows, whether that's on github.com, that's called GitHub Actions, or whether that's on gitlab.com, they have similar kind of automations. And of course, there's other, let's say, similar kind of Git-based version control repositories, which also on top of that, it's not just version control, but you on top of that add this automation, right? And that adds a lot of, and that's, again, that's encoded. There's a lot of standards coming from the community, right? Whether that's, POSIT, or also, for example, some stuff from the Roche IDR team, integrations and deployment and reporting team. There's kind of workshops on this topic, for example, at the upcoming user conference. So what I'm trying to say is R as a language, for example, but also Python and everything else is kind of complemented by these automated workflows provided by these external kind of cloud-based platforms, computing platforms. And that can enable a lot of things, right? It can enable things like automatically running tests on your that you're building, right? That are packages. That's of course very important. But it can also enable things like automatically compiling documents when you, for example, push some new data set. And that can be automatically deployed then, for example, on a website or something, right? And that can work externally if it's something open source, let's say, or public, but that can also work internally, right? So for example, Roche internally has a GitLab license, and we use those kind of workflows to really automate quite a lot of things. And that can really lead to this automation, right? Because people can then leverage this kind of unified system that they once learned, which is relatively simple. And you can also, let's say, use different programming languages to get in touch with the system. And then they can do a lot of things. They can be very, let's say, creative how they combine things together and how they say, well, if this data is updated, I want this and this to happen. I want a script. And then afterwards, I want to publish this on this internal website, or, whatever, send an email or create a PDF, and this will be available for download in this location, right? And that's, I think, really getting this automation done, right? And that's great, I think.
Oh yeah, that put it to a completely different level. Yeah, I think having everything kind of in this semi-automated way always, where there's still lots of hand maneuvering. Yeah, that makes it really hard. Another thing, of course, is this move here to the open source community that makes a huge change, because beforehand, or probably still, lots of companies automate that within their companies. And now there's more and more tools that are outside of the companies that everybody can use.
That's very important, yeah.
Yeah. Although I still think lots of companies have just spent so much money in developing company internal tools that it will be very, very hard for them to kind of move that around just because of this sunken cost bias. But yeah, that's my kind of view on that. All these SaaS macros, what do we do with that?
Yeah, no, I think that's really key to really scale up the number of users and the number of developers, I mean, even in a bigger company like Roche, I mean, it just wouldn't make sense anymore nowadays to say, well, for our 1,000 plus, statisticians working in clinical development, we just develop everything in-house. It just wouldn't make sense because you don't have enough users and especially you don't have enough developers, right? Okay, you can always, let's say, buy developers from vendors and something, but it just gets then too expensive, right? It's much better, I think, to see that so many things can be jointly developed between companies. Sometimes also academic parties are interested to use certain tools then and so on. You just scale up your user base, you scale up your developer base, and everybody kind of saves cost, right? And everybody kind of benefits from the better quality that you get. And again, as mentioned before, and it makes so much sense to base many of these, for example, workflows on really kind of public tools that are used for completely different things, right? Outside of statistics, outside of pharma, right? I mean, these GitLab or GitHub workflows, they're used for completely different stuff, right? And then you have this benefit. You have a much bigger user base. You have much more professional and bigger developer base.
Yeah, definitely. You talked about a couple of different tools, and what are kind of essential tools that people should use or that you recommend using that help with all the software engineering part?
Yeah, that's a great question. So what are the tools? Yeah, I mean, what is very critical, and I think I hinted to this before already, is that people learn to use Git. Okay, Git is the dominant version control tool nowadays. It hasn't always been like that. Of course, before there were other systems, and maybe in the future there will be similar other systems again. But at the moment, it's Git, and I think that's what we also see internally as a critical bottleneck when we do trainings for onboarding new colleagues or colleagues onto this new kind of systems where we use R and other open source things. It's learning Git, right? So definitely invest time, visit some workshops, visit the websites, learn Git. And honestly, I mean, if you manage to get to this kind of programming or statistics job, then you will also manage to learn Git. It's not harder, right? It's still much easier than all of the math and stats and whatever you learned before, right? But it just takes a bit of, it's like, I don't know, learning something that is not so much fun, but then you need to have it, right? It's like one of those things, right? And actually, when you can do it, actually, it can also be a little bit fun, okay? So Git is like critical. What else is critical, I would say, is to get familiar with good coding habits. Right? Starts from simple things like so-called clean code rules, right? Which is about how can we name things that people understand what they mean. Don't name your variables X and Y and Z, but name something that they actually mean, right? For example, cost and whatever value and probability or whatever, right? That is, and it goes to things like making sure from the indentation and styling of your code, people can it's kind of consistent. And there's many good tools, right? In R, there's lintar and styler to basically help you style and check your style. So there's many, many tools available. And of course, not just for R. So there's many of this kind of habits, right? And so on. And the other thing, which I think is really helpful, is like getting into this habit of code review, right? So that you don't just sit alone at your program and you just do everything alone. And then you have a lot of risk that you make some mistakes. You have a lot of risk that a second person will not understand this. You have a lot of risk that you yourself will not understand in 2 to 3 years from now. But that you say, well, it should be like a teamwork, right? It should be like a teamwork project, of course, not for some super experimental stuff you just quickly play around, but for, let's say, for production work, anything that's kind of goes into any kind of decision making, and that can be the sample size for the next study, that can be the submitted table for a regulator, that can be anything like that. That is a little bit important, right? At least just get into the habit of having somebody else look at your code, and of course, then also take some practice to give comments as a reviewer, right? You need to be nice, ask questions. Maybe there was a good reason that somebody coded like this, but there will be a lot of good ideas from you as a reviewer how to improve the code, right? And then with that, you really make sure there was at least 2 pairs of eyes on this code, and you have a much better chance of avoiding mistakes, of having this readable also in 2-3 years by somebody else, right? So I would say, version control, clean code rules, and code review is some key to start components.
Okay. Yeah, and it's great that there's actually some tools that help you with becoming better in these habits. That's pretty cool. Now, we talked a lot about R here. And of course, there's another software that many of us are using, and that is SAS. So in how far can we apply all these that we have, the lessons that we have for R, also to SAS?
Yeah, great question. I would say in principle, most of these habits and skills and tools apply to any programming language. And if we talk about SAS as in terms of the SAS programming language, then this definitely also applies, right? And it equally also applies to others like Python, Julia, C++, and whatever, right? I think I'm personally not so experienced in using SAS, at least for the last 15 or years. I did a couple of things in an internship, like, I don't know, 16 or 17 years ago. And I mean, to me, a little bit the question would be, is it possible to use the SAS language and then still apply, for example, things like automated workflows and so on, right? What we talked about before. That I would not be so sure. But in principle, and that's also what we, let's say, support here, for example, in Roche with our new data science platform called Ocean that a lot of people have been building up. And I think that looks very nice, is that we actually, it's a multilingual platform. It's not just R. There's a lot of SAS still, right? There's also the possibility to use Python and Julia and so on, and maybe other things in the future. And of course, many studies, especially for molecules that have started development years ago, they started in SAS, and it would have been too much work to now translate all the code to R. So they continue in SAS, and they will still continue their life cycle with SAS. And this SAS is definitely supported by this new platform Ocean. And, there's certain ways to automate things, and maybe it's using a little bit different, let's say, scripting language or whatever, but there's also ways to do that, right? And there's also ways to do that well. And maybe I also want to say, I think sometimes then also statisticians can learn from statistical programmers, in the sense, because statistical programmers have been using things like double programming and maybe code review as well for a long time, actually, right? And they have been talking about things like, okay, let's make certain things standard. It's not everybody write things differently, right? So I think we also should appreciate this experience, especially when you work in a pharma company, and, talk with your statistical programmer colleagues and see what you can learn from them, right?
Yeah. Now, how can people learn more about all these kind of different things? How can people learn to become better in terms of software engineering?
Yeah, great question. So the one thing I will make a plug is openstatsware.org. So that's a scientific working group, mostly comprised of statisticians, but also some programmers. So different backgrounds, but everybody's interested in kind of driving forward and contributing to the kind of open source package environment in statistics in particular. So what we do is we build packages on the one hand, we build them together in work streams to different topics, different packages. And we also try to spread the word about best practices. So we actually ran a couple of workshops already. So we did a little bit of a world tour last year. The last one I ran was in Zurich, and we will hopefully have more in the future. So keep definitely watching for those things to happen. And if you're already interested in package development, please reach out to us, openstatsware.org, if you want to get involved. Right? That's one, let's say, group of people that are really interested in this topic and also want to improve the topic. We will also try to make maybe some online versions of this kind of workshops now in the future to scale this a little bit beyond the face-to-face experience, scale this a little bit globally as well. So keep looking for that. And maybe a more general advice, have a look. I would recommend to have a look where there are opportunities in your organization to do this kind of thing. And look for those people that are already doing this kind of thing in your organization, right? Because whether it's in academia, there's many research software engineering or RSE groups popping up in universities and in academic research centers. So maybe have a chat with them, maybe see how you can get involved in a project together and that you can actually learn from them. And similar in companies, right? Pharma companies. But what we have seen through openstatsware.org is that actually many pharma companies also now have special teams that are working on packages and software, and that can be more in the traditional stats application, it can be more in the machine learning applications. But if you're interested to learn more, then definitely try to get in touch with them. Maybe they do some presentations, maybe they even have the opportunity for rotations, right? Temporary kind of allocations into their groups. And we have seen that at least internally here in Roche with the statistical engineering team that I built up. This has been working really nicely, right? We had people from all over the world from the Roche organization joining part-time into the team, and you just learn so much when you can do the work hands-on and get it reviewed and talked about with people that are experts in this area, right? And that will get you the real deal, and it will be a lot of fun.
Awesome. Thanks so much. So open software is, of course, a great thing. Now, there is case studies where you have this open software and then you want to kind of implement it within your company and get it kind of validated and all these kind of different things. And RPact is such a tool that has this kind of approach. Can you tell a little bit more about RPact and also how that relates to your company that you are now starting?
Yeah, thanks for the question. That's a great question. So RPact is our package specialized for adaptive clinical trial design and analysis and simulation. And that also includes things like group sequential designs, which many statisticians will be very familiar with. And I think has been a great example of a business model, how we can, make this work, that on the one hand, we have a super high quality implementation as an open source package, right? So RPact is freely available from Gran and GitHub. But on the other hand, how can we then make sure the people that are developing this package actually also get the money to do it, right? And it has been kind of a crowdfunding approach where companies and organizations kind of chip in to jointly kind of finance the development of this package, right? I think that's a great story that I've, seen a little bit from the beginning when I was on the Roche side, actually years ago, the first interactions. And then now I've also seen kind of maturing over time, and where I think, there can be hopefully more examples of this and maybe also other business models to make this work. And of course, I'm also super excited that, a while ago when I thought about, okay, what to do next, and especially with the relocation to Asia and Taiwan, what am I going to work there? And I'm so super excited that we chatted with, Gernot Wassmann and Friedrich Parke from RPact, and then we kind of line up this kind of joint venture with them to help them, build out further the kind of great work that they've been doing around RPact and maybe also other products, right? And this is basically the new Arconis, so spelled RCONIS. You can see more at arconis.com. That's a new kind of company that we have been starting now, and yeah, it's super exciting.
Yeah. definitely check out this homepage. There's some really exciting stuff happening in the future. And stay tuned. Follow Daniel, Friedrich, Gernot, and last but not least, Carrie, Daniel's wife, who's also a statistician and who is joining there as well. So thanks so much for that awesome discussion about what we can learn from Google, about software engineering, about tools, ways we can do better and actually get more out of all the things that we're doing and basically really automate the mundane stuff so that we can concentrate on the more important things. What's your final takeaways that you want the listener to have from this podcast episode?
Yeah, first of all, thanks, Alexander, for the invitation. Just having listened to a couple of episodes of the Effective Statistician podcast before, I feel very happy and humbled to be here. So thanks for the opportunity. And I think what to keep in mind is I would hope that many statisticians start to take software engineering and coding a little bit more seriously. So, try maybe next time you code something, try to think about polishing it a bit more, think about creating a piece of art. It's not just to get something done quickly. It should be something nice. And, it should be something like, I don't know, you're writing like a love letter to a partner or something. It should be something looking nice and something nice to read through. And I think if people invest a bit more into the quality of the code they write, I think it can help everybody to be more efficient, avoid problems, avoid bugs, and it will be more fun. And so maybe try out next time.
Awesome. Thanks so much for it.
Thanks, Alexander.
I very much hope you enjoyed this episode with Daniel about statistical software engineering. He is also giving a workshop at the upcoming conference, and I think just his workshop is already value enough for the overall price of the premium part of the conference. So check that out and get access to all the recordings and all the different workshops so that you get the full benefit of the conference. Just head over to theeffectivestatistician.com to learn more about the conference. This show was created in association with PSI. Thanks to Rain and her team at VVS who helped with the show in the background, and thank you for listening. Reach your potential, lead great science, and serve patients. Just be an effective statistician.